So now we're going to look at graphing trigonometric functions. We're going to start with the sine function. And we're going to be finding then the sine of x. We're going to make a little table of values. And so we're going to use the quadrantal angles. And I'm going to do the first quadrant, the special angles. So 0, pi over 6, pi over 4, pi over 3, and pi over 2. Now, you can use your unit circle if you want to use that as a reference, but you'll want to learn, the special angles. We are doing this in terms of radians. Now, that's important because we're graphing on a real number coordinate system, so we can't use the degrees, okay? Okay, so we're going to graph. Now, my lines are not straight. That bothers me, but it's the best I can do for the tools that I have. I'll have to research more and try to find better tools. I'm going to mark off, this is like my x-axis here, and I'm going to mark off 2 pi. Okay? Now 2 pi would be one complete time around the circle, right? Like, if you're thinking about this circle, it'd be once around the circle. Okay. Now, I'm going to eyeball this. I'm going to cut it in half and make that pi. Okay? Now, this is kind of how we graph these. We don't usually pull out graph paper because a lot of times it just gets in the way. But you can use graph paper. You may see some reasons why not to, though. Okay, if I cut that in half, that would be pi over 2. And if I cut between pi and 2 pi, if I cut that in half, and I'm just eyeballing this, that would be 3 pi over 2. Those then are the quadrantal angles. Okay, so that's when we were right. Let's see, I'll put it in orange. It was right here, right here, right here, and right here. Those would be then those quadrantal angles. I'm trying to put them in orange so you can see them. Okay? Now, 0 is still at the origin, by the way. Okay, so we still have 0 here. And then where would pi over 6 be? Well, pi over 6 is like a third of the way between 0 and pi over 2. So it's about, I'll say it's about right there, pi over 6. And I'll try to squeeze this in, pi over 6. And then pi over 4 would be halfway in between, so pi over 4. And then pi over 3 would be like 2/3 of the way, pi over 3. Now, we're not going to do this for every graph that we do, but I want to give you a picture of kind of what's going on right here at the beginning with the information that we know. Also, what is going to be the greatest, output that we're going to get? The greatest output we're going to get is 1. Now, this is probably not drawn to scale. It's not too bad. 1, pi is 3.14 approximately. So my 1 should be about a third of my distance between 0 and pi. Whoops. Oh, that did something. Okay, just keep going. All right. And then the lowest we're going to go is down here at -1. Okay? All right, now let's finish our table of values. The sine of 0 is 0. The sine of pi over 6, that's 1/2. That's the one I try to remember. The sine of pi over 4 is the square root of 2 over 2. And then the sine of pi over 3 is the square root of 3 over 2. And then the sine of pi over 2 is 1. And like I said, you can get that off the unit circle if you want. Now, I'm going to turn these into decimal approximations because we're going to be graphing these. So 0, 1/2 is going to be 0.5. And then what's the square root of 2 divided by 2? I don't know, so I'm going to get a calculator. Square root 2, square root 2 divided by 2. And I'm getting it to be about 0.7. All right. then what's the square root of 3 divided by 2? And I'm getting 0.9 if I round it off. And then 1 is just going to be 1. All right, let's look at what these points look like then. So I'm going pi over 6, and I'm going up a half, so it's about there. Oh, man. There it is. And then pi over 4 is a little bit higher. And pi over 3 is like not quite to the 1. Pi over 2 is at the 1. I wish I wouldn't do that. Okay, and so we get, by the way, 0, 0. I didn't graph that, did I? 0, 0. Okay, so we get this kind of curve thing going up here like this. Okay? Now, I can go in the next quadrant, and I'll go ahead and try to do that. I don't know if I have enough boxes. Okay, so the next one is going to be 2 pi over 3. So now I'm in the second quadrant. So back over here where I had my little thing, you know, if I'm going around, I did the first quadrant. Now I'm in the second quadrant. 2 pi over 3, that is going to also be 0.9. Okay, so it's the square root of 3 over 2. And then 3 pi over 4, that's going to be square root of 2 over 2, which is 0.7. Now all these y values are positive because we're in the second quadrant. And then 5 pi over 6 is going to be 1/2, or 0.5. So I'm going to get on the other side, between 1 pi over 2 and pi, let's see, that would be like 1/3 of the way, 1/2 of the way, and then 2/3 of the way. So it's at 0.9, then it's down at 0.7, and then it's down at 0.5. And then what happens at pi? Well, the sine of pi is 0. So it'll just be 0. So we're back here at 0. So it's curving back down like that. Now what's going to happen in the next quadrant? Well, we're going to speed things up a little bit here. Let's do 3 pi over 2. Well, 3 pi over 2, that's going to have the sign of that is going to be -1. So that's going to be down here. Okay? And so what's going to happen is it's going to curve down there. Now you could find those other special angles if you want to, but you can see that there's going to be a pattern. Okay? So it's going to be like -0.5 and then -0.7 and -0.9. And then down to -1. Okay, then what's the next quadrantal angle? 2 pi. And then we're back at 0 because the sine of 2 pi is 0. So we're coming back up here. All right. I was trying to draw it again so it'd be smooth. Okay, that is the sine curve right there. That's for one circle, one trip around the unit circle. Okay, now these continue in a pattern, so it keeps going up, and it would do another sine curve for the next time around the circle, and then another sine curve for the next time around the circle. Anyway, it would look better than that, but it's periodic. Okay, it's a periodic function, so that's what's going to keep happening. So, and these go on in both directions. Okay, so you can go back the other way. The domain then, so think about your x values, the domain is -infinity to infinity. The range though, my lowest point is -1, my highest point is 1. And so that's the range. Now this is for the function y equals sine x. Okay? The period, how long does it take to do one cycle? It takes from 0 to 2 pi. That is one cycle. I'll put this kind of in little things like that. So that is one cycle, one trip around the circle, and then it's going to start to repeat. So the period is 2 pi. Is there symmetry? Well, it turns out, if you remember, this is sine function is an odd function. So when we talked about even and odd functions, it means that sine of the opposite of x is equal to the opposite of sine x. And it means it's symmetric about, or sometimes I'll say with respect to, about the origin. Okay? So what does that look like? You kind of can't see it because of the way I have it drawn. But you have the sine curve going this way, and then it's going this way. Okay, so if you flipped about the x-axis and then flipped about the y-axis, the points should line up. Okay? So for symmetry, it's symmetric about the origin. Okay, so that's the sine curve, and we want to know the sine curve, so that's a really handy one to be familiar with. One thing that helps me remember is I remember the sine curve starts at 0, 0. That always helps me. Okay,